My name is Lee Gutkind, and I am the editor of a magazine called Creative Nonfiction. I'm also the distinguished writer-in-residence at the Consortium for Science Policy and Outcomes at Arizona State University. But more than anything, I think, at least to me, is the fact that I am a writer. I am a creative nonfiction writer, and I write about science and technology mostly, and I try to make science and technology interesting not only to the people involved in science and technology, but also to the everyday layperson audience, people who read the New York Times and the New Yorker and even USA Today, because science is so interesting and consuming and compelling. And so that's what I do. And the other thing that I do is I call myself an immersion writer. And what I do, lots of other writers do this, I immerse myself almost like an anthropologist into a milieu that really interests me for long periods of time. And the book I'm going to talk to you about today is called Almost Human: Making Robots Think. And it is the story of my immersion at the Carnegie Mellon University, that's in Pittsburgh, Pennsylvania, Robotics Institute. Carnegie Mellon's Robotics Institute is the largest robotics think tank in the world. And it happens to be right near where I sometimes live, in Pittsburgh. And so it was really terrific to be able to be there on a very regular basis and watch robots come alive. And so you could come with me if you want, and if you want to just kind of walk into the robotics center, you can go through one area called Newell Simon Hall, and then the other place that I really always like to go through is called the High Bay. Now, the High Bay is where the robotic scene is happening. The High Bay looks like a very large aircraft hangar, because there are so many robots roaming around all at the same time at the High Bay. There are, I have a little list here just of the robots that I noted one day that I walked into the High Bay. There were zooming robot segways who were learning to play soccer. There were robots on treasure hunts. There were nurse bots who care for patients in hospitals. There were robots that looked just like Lara Croft. There were robots named Pearl, Houdini, EnviroBlimp, Bullwinker, Grace, Gyrover, Ferret, Demeter, Rex, Xavier. There were robots that build other robots. There were robots that do origami, robots destined for museums as tour guides. There were robots that squirm along the ground just like snakes. There were robots that were made from pieces of golf carts. There were robots that creep like caterpillars. There were robots that are really pogo sticks. And there were robots that rolled, jumped, crawled, robots that honest to God look just like beach balls, robots that look like eyeballs, and robots that, when they move, fell apart. There were small miniature robots that were called millibots, and when you walk into the High Bay, they're all zipping back and forth, and for little regard for you and me. I mean, you have to really watch out, or the robots will get you at the High Bay. Now, what's really cool about Carnegie Mellon's Robotics Institute, and what's really cool about the whole robotics world anyway, is if you look around, all these robots, there are these children sitting there. I mean, people, little people. When I say little people, people under 21 years old, who some who don't even have beards, and they're sitting on boxes, on barrels, on ladders. They're sitting on one another, and they're hunched constantly in front of these computer displays, and they're writing code. And this was the first thing that I really discovered when I began looking into this robotics world. I thought when I came to Carnegie Mellon and I kind of ventured into the world of robots, I thought all the brilliant people would look just like me. You know, I mean, wild gray hair. We were all Einsteins, and we were the people sitting around and writing the code and making magic happen. But that's not true. We older people, with our gray hair, looking like Einstein. We raise the money, and we coordinate everybody else's activities. But what was so amazing to me was that all of this brilliant code, or at least most of this brilliant code that was being written, were being written by people who probably had never balanced a checkbook. They were kids. So that was really interesting to me, and that's one thing I wanted to say. It must be like Silicon Valley was in the 1960s with Steve Jobs and the Woz and Bill Gates roaming around, these children changing the world. And I think that's what's going to happen in this robotics world, that the kids are going to make the impact. And we're going to sit back and watch, and we were kids at one time, and we made an impact too. Not that the kids get along all the time. There are kind of two separate groups of people who build robots, roboticists. There's the engineer type, and then there's the people who write the code. They're called code monkeys. They call themselves code monkeys. And the gearheads call the code writers code monkeys. I should make that clear. And the code monkeys call the engineers gearheads. And there's this tension between them. What's more important? The people who build robots, who really mechanically make them do the things we want them to do, or the people who make them think? And there's this tension about the more important group and what comes first. Interestingly enough, in the world of robotics in the 1950s and 60s and even in the 70s, the gearheads had the power. They were building, because of course the computer power wasn't there. We didn't have what we have today in a capacity to make computers as strong and filled with memory as we did then. But slowly but surely, our computer capacity increased, the code monkeys took over. But there is this tension. And at one point, I ended up in the Atacama Desert, which is the place on Earth most like Mars. We were working on a robot for a while that we hoped would be perhaps the prototype of the next robot that replaced Challenger and Opportunity on Mars. And the confrontations got really dicey out there when you don't have a lot of support. What is really most important? Whether the robot functions in the sand, glides over rocks, or whether the robot is thinking clearly. And so that was another thing that really interested me, this constant pressure and tension between these two groups. The other thing that I want to talk about is the lack of and importance of women, okay, in the robotics world. Because my son is a student at Carnegie Mellon, and his biggest complaint is wherever you walk, there are no women. Okay? There are men everywhere, and that's the way at the high bay. There were men all around. I saw one time there was this robot that was dressed in pink. Okay? And I was really surprised, and I asked about it, and someone pointed at a sign. And the sign said, this robot was built by boys and colored pink by boys, and it was signed by the one roboticist there, girl roboticist named Brenna. But women have this innate sense how to understand roboticists and make them achieve. There was a woman there named Manuela Veloso. She was educated first in Portugal and then came to the United States and is an electrical engineer and has a PhD in artificial intelligence at Carnegie Mellon. And what annoyed her about the whole robotics world, not just at Carnegie Mellon but everywhere, was the fact that guys couldn't get along. The male scientists couldn't get along. They would not share their code, okay? They would not share what they knew with everybody else. And Manuela was not only brilliant, but a great peacemaker. And she tried to figure out how in the world can I get these guys to all cooperate and share what they know so that we can enhance this whole robotics world much faster. And so how do you do it? She knew innately that men were incredibly selfish and incredibly competitive, okay? And so how do you get a man to give? You challenge a man. You make things competitive. And what is, in an international world, what is more important to a man than anything else? Soccer, okay? So she decided that she was going to form this league called Robocup. okay? And she was going to get as many people in the whole world of robotics interested in training, building robots so that they could play soccer. Okay? And we're not talking about remote control soccer. That's not what's happening in this whole robotics world. It's autonomy. How can you get a robot to play soccer or to do anything all by itself without the man or the woman behind the robot telling it what to do? So she challenged men to do that. And she formed Robocup. And she started to build a worldwide league with one of her students who worked for Sony in Japan, working together. And here was the thing about Robocup that really made it really interesting. The challenge was that you made a team, and you played against one another, but the real overall goal was that within 50 years of the first year of Robocup, 2003, within 50 years, somebody would make a team of robots that would play the World Cup human champs and beat their pants off, okay, and win. So that was the challenge that Manuela Veloso sent out to the whole robotics world, with this exception. You want to play Robocup, you got to share your code. And so she launched this in 2003. There are now Robocup tournaments all over the United States, all over the world. There is an international Robocup tournament that goes on every year. It's been in Portugal, it's been in England, it's been in Paris, it's been in the United States, it's been in Germany, all over. Hundreds of thousands of people come for this 10-day event, interested in seeing what robots could do. For a long time, the robots that played Robocup were Aibo dogs, little Sony Aibo dogs. You ever see those Aibo dogs? They look like little beetles, okay, or beagles. They look like beagles, and they walk, they talk, they're nice, and also they're a little ornery, because that's the way dogs are. They're so real and so cool in many respects that one time, doing some research, I flew to Central Park to hang out for a day with a dog walker, professional dog walker, who walked a couple of Aibos for their masters who were going to work. So the Aibo dogs played Robocup very often. So the challenge was not to build the robots, they were just there, but to reprogram them. And so they could push this ball. It was like a wiffle ball about twice the size of a tennis ball. And they could push the ball, and they acted like a team. They could pass it back and forth. They could think like a team. When they sensed the fact that they should be defensive, they went into a defensive mode. They communicated with one another as to where they ought to go and what they ought to do. They switched to offense when it was acceptable. It was very cool. I mean, these are little Aibo dogs, so they kind of pushed the ball along, and they weren't incredibly talented, but it was really interesting, and the fans really went kind of crazy. But this is the other thing I learned about robots, okay, and roboticists. We all think, we have been brainwashed by the media to think that robots are going to take over the world, that robots are going to fight our wars and take care of our elderly and cook our dinners. Maybe someday, maybe a long time from now. But this is the other thing that I noted, and that is that robots will let you down. Robots are not necessarily ready for prime time, especially when they play soccer. And I just tell you about one game that I watched. It was a big deal, USA championship game between the Carnegie Mellon Robotics soccer team and the Georgia Tech Aibo Dogs soccer team. It was very exciting. There were about 1,000 people in the audience, and they got very involved in the game, and the game went back and forth. Georgia Tech was winning, Carnegie Mellon was winning. It was quite exciting, and almost at the end of the game, one Aibo dog from Carnegie Mellon had its way all the way down the field, all by itself. Defender somewhere had fallen away. Even his teammates, or its teammates, had fallen away, went all the way down the field and stood right in front of the soccer cage without a defender. If that dog could have pushed with its snout or pushed with its paws just just pushed a little bit, that ball would have rolled in, and Carnegie Mellon would have won the Robocup championship of the United States. And the crowd was going crazy. And they're yelling and they're screaming. And somebody yelled really loud, "Breathe on it, for God's sake. Just breathe on it." Because you get involved. You forget that they're robots and they're not real. And the robot stood there and looked at the ball and looked at the cage and reared back. And we all knew that that robot was going to push the ball into the cage and Carnegie Mellon was going to win. And suddenly, after a great pause, the robot turned and ran the other way. So, you can't quite rely on robots just yet. So, that was another lesson I learned, that roboticists are making a great deal of progress, but they're not quite there yet, and robots aren't quite there. They're not going to take over the world quite yet. And I'll tell you about another robot, which kind of proves that point as well, called Grace, graduate student attending a conference, okay? Grace was the first. Grace made history, okay? Grace was the first robot to ever attend an international scientific conference and give a talk. And it was very cool that day. We followed Grace through the hall. Grace, all by itself, got up, went into the elevator, went up the elevator, got off at the right floor, and then started going down this big, large floor, kind of moving through the exhibitions area. And one thing that I should tell you, that the Carnegie Mellon people are so cool in the kind of software they do, that they made schmoozing software for Grace. So Grace could schmooze. "Hey, how are you? How you doing? Nice to see you. Looking good." Grace went all the way through up to the registration booth. But the registration booth had a big line, and Grace evidently saw the line, but smashed into the beginning of the line, pushing people away, and went up there at first because they forgot to write standing in line software. So everybody has to remember that the robot is just the person behind the robot who is writing this code. And you have to really, writing the code is really hard, because you have to figure out, especially if you're writing code for kind of a human like robot, if you want the robot to do things that are kind of human, writing the code is quite interesting, quite difficult, because you have to figure out what it is you want the robot to do, and you have to tell it every single syllable, every single movement or thought. You have to be able to write code to communicate that to the robot. So I want to just tell you about one other robot, because I started this talk by talking to you about entering into the robotics world at Carnegie Mellon through the high bay, which is this big aircraft kind of hangar. But if you want to go in the front door, you can, okay? Newell Simon Hall. And if you go in the front door, there's a robot receptionist. And when I started working at Newell Simon, Valerie was the Robotics Institute roboceptionist, actually, and she would greet visitors. She had these brilliant blue eyes that kind of gazed at you, and she smiled at you when you passed by. And like most receptionists, Valerie spent a great deal of time, what do you think, talking on the telephone. So, and people really liked eavesdropping on Valerie, because she would talk to business callers and she would talk to friends. And then she had this favorite person she talked to. She called her parental advisor, or in robot language, her motherboard, and got advice from her motherboard as to what to do. And she was in her own life, and she was a interesting character, that the same kind of character you might meet in a regular office. And she also revealed intimate conversations that she had with her psychiatrist. The first time I met Valerie, she was really angry. She was fuming because of a really disgusting and unsuccessful date that she had with a guy named Vern, who was a vacuum cleaner. So she said, when he wasn't ignoring me, he was trying to give me a hickey with his nozzle. She really complained. I mean, what kind of robot does he think I am? A hickey is definitely a second date event. Now, a better dating experience, Valerie told me, occurred when she had an evening with the Chevy Impala. We went to a drive-in to see the Terminator. It was very romantic, all that blood and technology. You see, the more real robots seem to be, according to one of the researchers that I spent time with, a guy named Reed Simmons, who wrote most of Valerie's software, the more time people will spend with a robot learning about them. And this idea of human-robot interaction is very important, and people can now get master's degrees in human-robot interaction because indeed robots are becoming more important all the time, and we think they're cute, but we're also really quite afraid of them. I mean, how do you communicate to a robot? So Reed Simmons tried to make robots as real as possible so that people like us would feel better about dealing with robots. So when there was a lull in the conversation, Valerie often talked. One time I walked in there and I said, "Hello, Valerie," and she said, "Did you know that my mother's getting married next month?" So Simmons analyzes thousands of interactions between robots and the people that he deals with every day. And you walk in, and in addition to requesting information and directions and even the weather report, more than 1/4 of the people asked Valerie how she was feeling and asked questions about her personal life. About halfway through my experience, Valerie was replaced by Marion LaFleur. They called Valerie's replacement Tank. And he was the son, according to the software and what he told us, of a NASA scientist who had aspired to be an astronaut, but the poor guy was grounded because of vertigo. So Tank was a much more complicated person than Valerie. It was a fact that you can recognize by the way he responded to visitors. He didn't like people who were too personal or too flippant, and I would try him out once in a while. And I once literally banged on his keyboard just to kind of wake him up. And he said to me, "I cannot waste my time with you fooling around." And later, that same day, I saw him talking to a really pretty blonde woman student. And I snuck up afterwards and sent Tank an intimate message. "I love you," to which Tank replied, "You don't even know me." So I didn't know Tank. And Tank didn't know me either, I should say. But that was part of my experiences. These people were quite dedicated. If you want to find a roboticist, you don't look for them during the day. This high bay experience, everything happens at night. It's dark at Newell Simon Hall, and the robots come out sometimes, and they kind of sneak up on you. And you walk in there in the morning at 6 a.m., people are leaving. There are empty pizza boxes all over the place. There are plastic and wooden chopsticks thrown all over the floor. Everything seems to happen in this robotics world at night. And one time, I went up into the classroom area, just kind of wandering around at 3 or 4 a.m. I got scared to death because there were hordes of robots up there. These young people brought their robots out at night very often. That's when they could really play with them. So that's the Carnegie Mellon Robotics Institute. My guess is that the world of robots is like that almost everywhere. It's kind of a new, secret kind of world that's slowly going to become a part of our lives as we progress. But don't be afraid of losing your day job right now. You've got a long way to go before the robots take over. My book is Almost Human, Making Robots Think. It's on sale everywhere, and I thank you for listening to it.